Start.
Good morning,
Sorry again.
everyone present at this conference. I am going to expose the next research, which was prepared by Ismael Garcia Paez, Camila Araque, and who speak Juan Manuel Carrero. This presentation is titled Grow Matter Design, Symmetry, Structure, and Information. This research proposed to grow inert matter. It means to work with the phenomena of mineral aggregation typical of nature to create functional structure in architecture. This theoretical assumption in architectural design is developed in this research far from orthodox models in architecture and within a critical experimental space, with borders with the abstract materialism suggested by Zizek. In the specific case of this project, the phenomenon of aggregation of mineral concentration in supersaturated watery environments in proximity to seed particles was observed and experimented with the objective of understanding what principles of self-organization underlie this emerging phenomenon, and how to direct and scale this aggregation to understand the structural and spatial potential of this phenomena within architecture. So, it is important to point out that nature-based design was being part of man since its origins. This fact is usually linked to architecture through concepts such as mimesis and inspiration, which allows the designer to represent objects external to it. However, this project differs from these ideas of imitation and is closer to the concept of scientific knowledge to face the cultivation of matter itself as a design technique. It makes it necessary, in a sense, to transfer the experiential reality to the objective mathematical and abstract reality. In other words, this is to create informed matter. It means a discrete set of objective factors about a fact. And in another sense, is demanding incorporating this provisional knowledge into the making of the design. This supposes in this research to tune the human will with the will of nature. The method was organized in three parts. The first one of experimental observation, the second one of modeling and simulation, and the last part of experimental direction. In the first part, structure of crystalline aggregation were obtained by a solution of potassium alum solute supersaturated. This saturation worked as driving force for solute nucleation. This crystallization method encouraged the formation of nucleation structures or particle aggregation, which facilitated the random measurement of particles in the x, y, zeta axes. This formed the Excel database for this research. In the second part, the digital matter was informed by the capture data generating a digital model simulated in a visual programming editor like Rhino's Grasshopper. The proposed model reflected the crystallization method exposed above. It also translated the aggregation phenomenon by encoding the time of apparition of nuclei and the coordinate of the emerging of these particles. All this is within a Cartesian digital space around the specific perturbation. This simplification of the phenomenon means excluding the continued disturbance of the rest of the environment owing to particles growth. And the same and At the same time, it's demanding using this spatiotemporal data of the apparition of the aggregation as the only guide to understanding the trajectory logic of the phenomenon. This highlighted the relevance of the volume of data to visualize in Grasshopper, its directional dynamic, future scale, and the cognition of the phenomenon. We start exposing the need for more data to extend the logic of the trajectory. This need demand the use of machine learning probabilistic projection technique to refine and extend the original data. And for example, an oversampling method with a Gaussian mixture model was used for this purpose. This probabilistic method was performed in particular with the help of sklearn, the most used library for machine learning in Python, deployed within the platform of the developer Anaconda. This developer provide accessibility to open source algorithms within data organization, graphing, analysis, and projection libraries such as Panda, Matplotlib, and NumPy, and Seaborn. The person imagined in the screen is the final definition of the simulation of the particulate aggregation process studied in a rhinoceros grasshopper environment. This simulation can be summarized in four parts. The first, upper left, corresponding to import of the data input. The second, lower left, serves a timer. The third in the center locates x, y, and zeta in Cartesian space. And the last visualize the model in Rhinos grasshopper is output. This output we can see in this image exactly. The image in red is the process, and the other image is the result of the 3D simulation with the Gaussian mixture model data. Finally, in the third part, we experimented with the directionality of the studied phenomenon, whose activation was made through the calling method explained at the beginning. It was exposed to temperature delta as well as the setting of elements external to its environment. In the case of the test with temperature delta, it was developed in 2 mm layer of the solution, and the heat source was located at one in the test area at maximum temperature of 60 degrees with a limited gradient of 24 degrees in opposition to the emitting point. In the case of element setting, particle stirring in the supersaturated solution was tested in the presence of physical perturbation within a 60 mm deep cubic vessel. For example, a tree was planted in the middle of the solution and the surface of its container were used. That is, a line and a plane were planned to measure three-dimensional and two-dimensional aggregation respectively. The result the observation proved, as expected, that this aggregation phenomenon could self-organize in relation both to the energy level with which it interacted and to its environment. Specifically, in this phenomenon, the particles emerged and were self-organized driven by hydrodynamic force, Brownian motion, and rules of low level of sophistication. The
Eugene,
particles
please mute
reach
yourself.
a structure in a state of high complexity when there is an exchange of matter and energy with the outside. That is system far from equilibrium. Very far. Likewise, change of direction in the aggregation process were appreciated. Is happened whenever the development of self-organization was perturbed, either by its emergent environment or by the continued alteration of this by growth or aggregation of particles. However, this aggregation of particles around this perturbation, like the aggregation free of this, always tending toward orders or omnidirectional symmetry accretion. For example, like the imagine in the first case, it was observed that the aggregation tended to an ellipsoid is we consider the Seiden line or treat as an axis of symmetry. This ellipsoid maintained its scale as long as homogeneity of the auto-organization and environment was preserved. In the second case, a grid was drawn on a plane, and as expected, the particles were aggregated on both sides of their lines. When the aggregation intersected, they tended to inscribe circles inside the square of the grid, like you see in the image. Uh, we experimented with trajectories in a plane at a shallower depth and at a scale 100 times larger on a layer of supersaturated solution. This case preserved the omnidirectional symmetric accretion, particles tendencies, and reinforced the accretion phenomenon already observed. The aggregation tended to get together in pairs, subgroups, and cluster until forming a large disk on the surface, as shown by the mathematical model of Kamasa. Uh, this same layer was subjected to temperature deltas without changing the omnidirectional symmetric accretion trend described in the previous paragraph despite change in particulate concentration and growth. For example, as the particles approached the heat source, they expanded and decreased their growth. In other words, the particles reflected the heat spectrum. In the discussion, to begin the discussion, it is important to recapitulate and recall that this article primarily investigate how to grow inert matter based on the phenomenon of mineral particulate aggregation. Specifically, it explored the directionality of this aggregation and their potential for the design and generation of useful form for architecture. which place this research in the same line of the Hartmann, Luhin, Luhindich, or Carrero and Quadros, and especially coincide with the Camasa and Load, who supported on similar phenomena to those of this research observed an omnidirectional creation in the aggregation of mineral concentration to seed particles. However, this research disagree with the result of the aggregation trajectories model simulated by the latter author, Lot. Unlike those um, grow matter design, they did not obtain ellipsoidal aggregation trajectories equivalent to those tested with the material, but rather continuous and homogeneous linear trajectories. Moreover, also, it was possible to manipulate the shapes of the phenomenon with temperature delta and to model the trajectories in a plane and align the project facet problem with the continuous alteration of the rest of the environment due to the individual growth or grouping of particles. This made it impossible to account for possible geometric hierarchy and symmetries around the trajectories of more complexity. Therefore, it postponed experiments to ensure the directionality of human designing trajectories or to explore the self-construction of space. Finally, it can be stated that the result of this project validate the use and directionality of the forms of self-organization of structure as possible future for design, which introduce architecture in a new paradigm, enabling it to understand nature, not only to imitate it, but also to participate in its formative dynamics. At last, this project acknowledgement. This project would not have been possible without the help of the University Francisco de Paula Santander and the support of these simulation and fabrication laboratories, Simulab and FarLab, and research group GDIMA and Design Lab. We are also grateful for the contribution of physicist Joseph Fabrizio Bergel with the development of the oversampling code implemented in Sklearn, as well as architecture student Pablo Rey for this advice with the Grasshopper, and of course to each of participants of the Grow Matter workshop 2019 who in their last years of architectural design accepted this challenger. Okay, thank you very much. I hope to see you in the next conference. Bye. Thank you.
Thank you, Juan. Thank
Okay.
you. Forgive me for the problems in the beginning, but
No.
we hear you and see you loud and clear. I'm always amazed with what Grasshopper allows us to do. So this was one more experiment interesting to see that was performed with Grasshopper. Does anyone have questions for Juan?
No, I have a question. I would like to ask about how you see application of this study for architecture. What kind of how architectural design you see could be informed by the results of your research?
Okay, it's a good question. My objective is to tune the how do you say, the wheel. I see. Okay. My object in this research is to tune the human will with the will of nature. Of the architect always, how do you say, draw, and thinking the design only for the representation and draw, But for me, the reality is dynamic, It's impossible, like architect, to continue design only object, static object. I don't always in my life I question that why I, like architect, I design for this dynamic reality, and when I finish my design, I stop and building this design and it's static, but the work is dynamic for that. When I start to think about this, I think the nature is important understand this nature and start to see how the nature to direct how this nature can form for space and structures. This research is in beginning, but it's important that people people like me, architect, start to thinking about how you can direct of nature, and for create a space. You don't have to draw all the time. You have to understand the nature, and you can maybe it's the future. Okay, no, it's maybe now you can see this kind of design, but it's in beginning all. No, for me the objective is start to understand the structures and space with this kind of aggregation is possible, but in my laboratory, in my group, research group, we research about another kind of nature, like sediment or river, for example, for how do you say that? Okay, my group research about the nature and the dynamic of nature and how you can see the design. For me, for example, if I speak about the sediment of river, when the river is dynamic river and bring a lot of sediment, when you do some project, you can see you can think the project in dynamic, during this dynamic, you can see how the river, for example, can put sediment, and you can work, or you can one day, another day, no. You have to take a plane, a map, to map with time. You can see the map and you say, today the river is maybe in this form. Tomorrow or the next week is the other form. And you can start to beginning the nature is dynamic, and you can see in this. This is an example, but in particular in this research, I think you know I don't know in English how do you say that, salts, the camp, the the salt when the how do you say,
evaporate water for getting salt.
yes, when it start to go the the temperature change, like my process, you can see the different space and structure, you know, and you have, and I think it's important think about this phenomenon to understand the nature. I repeat, this is a beginning, but this is my objective. The conception of architecture, dynamic, like dynamic. I don't know if I can see that. I can say that architecture like life, like
organic architecture. Yeah, I understand. But do you see it more like design, like urban design? Because urban means city, for instance, or town design. Because this kind of research, I know that already existed about emergence. Yeah? And for instance, Steven Johnson gave example that if you look at the map of cities which were developing naturally and brain, basically it looks like the same picture. Yeah. So, but this is about something like development of the city. But do you also think about development of like building?
Yes, I think the building is alive. It is and the building can take life and all the time change, maybe. This is at the beginning of it, but there are one project, I think it's a moat of sand in Netherlands. When you put a lot sand and the nature, okay, it's impossible to explain now. Okay, there are.
I understand.
Yes.
So you also think about some kind of growth of particular architectural units like buildings or centers, something like this. Okay, I understand. Thank you very much.
Okay.
Okay. There are many researches on with parametric modeling with sandform structures and aggregations of cells as you are exploring. So it is interesting to check those out. Okay, Martin, may we go for another presentation? Is there any question more for Juan? Time is very limited. Is there any question?